August 2006, Prague. It was in this city that the fate of a certain celestial object was changed significantly. For 76 years, we believed that there were 9 planets in the solar system. The planet we've always known as being the furthest from the sun shares its name with a popular cartoon character. That's right, Pluto. However, at the Triennial General Assembly of the International Astronomical Union, this long-held view was turned upside down. Pluto lost its status as the 9th planet of the solar system and was demoted to the rank of dwarf planet. 7 months earlier, NASA had launched a probe with the mission to study Pluto.
I think Pluto is special to Americans for a couple of reasons. One is because it was discovered by an American, and I'm sure that if there were planets discovered by Japanese astronomers, the feeling would be the same.
In July 2015, after a 10-year journey, the probe finally reached Pluto.
Okay, copy that. We're in lock with telemetry with the spacecraft.
This image gave humankind its first ever close-up view of Pluto. Tall mountains that dwarf even the Alps in Europe. Sheets of ice that move like glaciers. What we used to call the 9th planet of the solar system was a world of abundant ice.
If you were to land on Pluto, it looked just like this: glaciers and mountains.
Pluto lies in a region of the solar system yet to be explored. Its secrets are now finally being revealed. Our journey of discovery will take us to the very edge of the solar system. The first stop on our trip, however, is Flagstaff, a city in Arizona. Flagstaff has been a key junction between East and West since the pioneer days, and it was here that Pluto was discovered. Our story takes place on a hill overlooking the city, home to Lowell Observatory. It is one of the most historic observatories in America. In the early 20th century, a great effort was put into the search for undiscovered planets. The world was in the midst of the Great Depression at the time. The hero of our story is this young man. Hailing from a farm in Kansas, Clyde Tombaugh loved stargazing. In 1930, he had finished his first year at Lowell Observatory, working as an assistant with the task of checking photographs. The young Tombaugh noticed a stain-like dot that was moving with time. By calculating the distance based on the speed of its motion, compared to the stars in the background, it was confirmed to be a new planet beyond Neptune. Up until then, just 2 planets had been discovered using telescopes: Uranus and Neptune. The astronomers that discovered them had all been European. And then a young American came along and beat astronomers around the world to a huge discovery. Another planet had been discovered. The exciting news made a welcome change for a recession-worn America. The new planet was named Pluto, after the Roman god of the underworld. Boosted by the discovery of a new planet, the USA continued to dominate the field of space research after the Second World War. In the 1960s, they sent out the world's first probes to Earth's neighbors, Venus and Mars. In the 1970s, probes reached Jupiter, Mercury, and Saturn too. The Voyager program was to be the grand finale of this exploration of the solar system. The program was prompted by a proposal from a graduate student who noticed that all the planets beyond Earth would be aligned in the same direction at the end of the 70s to the 80s. Two probes were launched. One was to explore the 4 planets from Jupiter to Neptune. The other had the possibility of heading to Pluto after passing Jupiter and Saturn. However, even though the 2 probes were launched, Voyager never did go to Pluto. Ed Stone is project scientist for the Voyager program. He says that the presence of a major rival along the way was the reason they gave up on Pluto.
Voyager 1 could have gone to Pluto, but it would have had to fly by Saturn more or less in a trajectory like this, which meant that it was not staying in the plane of the planets. And we could not fly by Saturn's moon Titan if we'd done that. So the trade-off was, do we explore Titan, which is a big moon of Saturn, which puts us on this trajectory, or do we try to go to Pluto, which puts us on a different trajectory?
Titan is an extremely interesting celestial body, with an atmosphere similar to that of Earth. In the end, Voyager headed for Saturn's moon, Titan. There were several reasons why Pluto was not chosen. Pluto takes 248 years to orbit the Sun, and its orbital path is at a 17-degree incline from all the other planets. In order to reach it, the probe would have needed to change direction significantly mid-mission, which was deemed too risky. Furthermore, as detailed observations progressed, it was becoming clear that Pluto was much smaller than imagined. It was supposed to have been larger than Earth, but by the late 1970s, it was confirmed to be smaller than Titan. Not even Voyager could realize the dream of exploring Pluto. For one man in America, however, achieving this goal has been his life work.
Kind of eating into this terrain.
Alan Stern is the principal investigator of the Pluto exploration program.
Multiple connections that is not entirely dendritic.
He has been captivated by the mysteries of space since he was a child. When Voyager was launched, he was still in his teens.
Well, I remember Voyager very well because I was watching, although I wasn't a part of those projects, I watched the Voyager flybys of Jupiter and Saturn and Uranus and Neptune. I was swept off my feet. I remember the encounter with Jupiter best. The images were coming down of the worlds that orbit Jupiter, of its moons like Io and Europa, and they were just so strange and exciting and beautiful that it opened my eyes. I was an engineer, studying engineering at the time. It opened my eyes to the exploration of the solar system, and it made me want to become a scientist.
Inspired by this image to become a planetary scientist, Stern went on to research Pluto. In 1989, when he was still a graduate student, Pluto experienced a special event. It reached perihelion, the point at which it is closest to the Sun. If we look from above at where Pluto was at the time, we can see that it was actually inside Neptune's orbit. That same year, a group of researchers gathered in Baltimore on America's East Coast to discuss Pluto. Stern reflects that the conversation they had that night at a restaurant was what started off the whole exploration program.
This year's perihelion, so Pluto's going to get further away from now on.
Right, so
Obviously.
we've got to act now so that we can explore Pluto at its closest point.
That's so true.
Yeah, but it takes Pluto 248 years to orbit around the Sun.
Right, so this is literally a once-in-a-lifetime opportunity. We are the generation of young
Stern
scientists,
was at the center of
right?
proceedings.
Let's make it happen.
Do it.
So, what are we gonna do?
I think we should let the world know how important it is that we explore Pluto.
But how, specifically?
Or we could write a letter to NASA.
It makes sense to me.
Yeah.
All right.
Cheers.
Pluto.
All right.
I was still in graduate school, and I had never been the principal investigator of any spacecraft experiment, much less a whole mission. So I never thought of myself as leading it. I only thought of myself as someone who wanted to help make it happen.
Some of those who were present that evening are now involved in this exploration mission. Fran Bagenal of the University of Colorado Boulder is one such member.
When we started this campaign to try and get a mission to Pluto, we called ourselves the Pluto Underground. And this was a throwback to the 60s and 70s when some of the groups that were campaigning to make change called themselves the underground, movement of this underground, that underground, and we were the Pluto Underground.
Stern and Bagenal paid NASA a visit right away.
We had a short meeting, and I told them the reasons that we thought it was important to study how to go to Pluto. And he said to me, "No one's ever asked me before about a mission to Pluto. I think it'd be a great idea." And I was very surprised, very happily surprised, because I thought we would get a no or an uncertain answer, but he was very enthusiastic.
NASA immediately set up a working group to look into the possibility of exploring Pluto. The team included the two young scientists. Meanwhile, a certain discovery was about to be made in the world of astronomy. And it was to give a boost to Stern and his colleagues. From the 1990s, the technology of digital cameras, which revolutionized photography, began to be used in astronomical observations. Thanks to this new technology, stars 100 times fainter than what could be observed before could now be captured. Then in 1992, a celestial object with a similar orbit to Pluto was discovered. After this discovery, similar celestial bodies were found, one after the other, around 1,700 in total. This cluster of bodies is known as the Kuiper Belt. It is a collection of small celestial objects made largely of ice. Pluto was not just a small, oddball body, but part of this major presence within the solar system. The passion of the young scientists and the discovery of the Kuiper Belt. These two factors combined to push NASA into action. "17 years had passed since that casual conversation at the restaurant. Finally, a probe was launched, headed for Pluto. With the hope of exploring new frontiers in the solar system, the probe was named New Horizons. The distance to Pluto is 4.8 billion kilometers. The journey would take 9.5 years. The exploration team started observations of Pluto before New Horizons reached its target. The instrument they used was the Hubble Space Telescope, flying at a height of 600 kilometers. This was the image of Pluto captured by Hubble. Being so small and far away, this was the best quality image of Pluto available to humankind. We're back at Lowell Observatory, where Pluto was first discovered. Here, there is a scientist who is keeping alive Tombaugh's legacy of studying Pluto. This is Will Grundy. Grundy's group has succeeded in discovering more about Pluto's appearance by layering over images taken by Hubble. The data garnered from 384 images captured over the course of a year resulted in this. The surface is patchy, covered with bright regions and dark regions.
And they're bright, presumably for the same reason that snow or a white sand beach is bright on Earth, which is that it's made out of fairly transparent materials that scatter light.
So what are these transparent materials? We asked Grundy to do a reconstruction. A vacuum chamber is filled with the same gases that make up Pluto's atmosphere, and the temperature is lowered to minus 230 degrees Celsius to mimic the surface. After a while, a pale substance appears. This is ice made out of nitrogen. Grundy believes that it is this nitrogen ice that is covering Pluto's surface like snow or frost. But why are there both bright regions and dark regions? According to Grundy, one possible reason lies in the seasonal changes on Pluto. Pluto's axis of rotation is tilted at a much greater angle than that of Earth. This means the amount of sunlight that it gets can differ greatly over the course of its orbit, and therefore, seasonal variations are more extreme than on Earth. In areas experiencing summer, when there is plenty of sunlight, the nitrogen ice evaporates from the surface, which then becomes gradually darker. Meanwhile, in areas that are in winter, the gases freeze into snow and frost, covering the surface and making it appear pale.
When you look at Pluto with Hubble Space Telescope, you see that it has some very bright regions and also some very, very dark regions. We want to know what these regions are made out of, and hopefully the images that we get at higher resolution will reveal what processes at work.
On July 14th, 2015, the day the exploration team was waiting for finally arrived. At the control room at the Johns Hopkins University Applied Physics Laboratory, a crowd was gathered. Among them were scientists who had dedicated themselves to the research of Pluto. At 7:49 a.m., New Horizons made its closest approach to Pluto.
9, 8, 7, 6, 5, 4, 3, 2, 1.
26 years had passed since Voyager's exploration of Neptune. And a new milestone in science was created.
Well, it's the first time I've experienced it, right? So we've been working towards this for a long, long time. So we kind of know we've practiced all the parts. We've kind of been through every part of it except for you guys all here.
New Horizons is a big team, and our flight control team is just unparalleled, but there are a lot of other people on the New Horizons team. I want to say to you just 3 words. We did it.
That day, an image taken by New Horizons was revealed. It is light brown in color, with a diameter of 2,370 kilometers. Various terrains are captured, but what stands out most is the brilliant white heart-shaped area in the middle. For Grundy, who had proposed that the bright regions represented nitrogen ice, it was a far more complex image than he had ever imagined.
As Pluto rotates, when this thing is oriented towards you, you see stronger approach.
In Pluto's northern hemisphere, winter has just finished. It is thought that the North Pole appears white because of the thick layer of nitrogen ice that built up over the long winter. However, seasonal changes cannot explain the white heart that lies near the equator. It was a mystery.
We haven't found any good reason to concentrate the stuff on this particular region. Probably some number of months, somebody's going to come up with a very clever idea that explains all of this, all of the pieces, and I really hope I'm in the room when that happens, because that's always a very exciting time in science when you go, aha!
In September 2015, 2 months had passed since the Pluto flyby. Images with even greater detail started reaching Earth. The exploration team is using these images to try and work out what kind of world Pluto is. One of the team members is Bill McKinnon, a planetary geologist. This image was created using multiple layers of images and is 16 times the resolution of high definition. Features such as craters of varying sizes and valleys that crisscross the surface are captured with great clarity. Here, we see a rugged mountain towering over a flat expanse. It could also look like an iceberg floating on the sea. The tallest mountains are thought to be around 5,000 meters. There are also features that look just like volcanoes, with central depressions similar to calderas. But it was at the center of the heart that a discovery was made that took scientists by surprise.
And over here, you can actually see stuff that is apparently coming down through valleys and then spreading out. You can almost see a little edge here, probably carrying ice blocks with it. And I think there's another one down here. If we go farther, it's hard. Oh, yes, beautiful, beautiful. So stuff is accumulating. This is actually at higher altitude, and it comes down here and then fans out all around here.
Of particular interest is this area, where it looks like something is flowing downwards. Even the narrowest part is 3 kilometers wide. This type of landform, captured by New Horizons, can also be seen here on Earth. We asked McKinnon to show us. This is the Athabasca Glacier in Canada. It is 6 kilometers long and 1 kilometer wide.
Well, we're here on the Athabasca Glacier. It starts there up at the top, the Columbia ice field. Lots of snow every winter. It compacts, turns to solid ice, and flows downhill like a river.
On Pluto, the substance that is equivalent to water on Earth is nitrogen. McKinnon believes that the nitrogen that falls at high altitudes on Pluto forms moving glaciers.
You can always predict something like, oh, there are going to be craters on Pluto, and there are going to be cracks. But you would have been laughed at if you said, we're going to go explore glaciers on Pluto.
It is suggested that the heart is a concave area where nitrogen glaciers have flowed into. In other words, a sea of frozen nitrogen. Because this nitrogen sea keeps moving slowly, like glaciers on Earth, it is expected to carve out a complex terrain.
See, right here under the ice is actually a little puddle of slush and water. We can imagine that on other planets and satellites we'll see things like this. And since the glaciers and glacier ice on Pluto made of nitrogen, you might find little puddles of liquid nitrogen. Of course, if they were exposed to space like this, they would start to boil rapidly and you make a kind of geyser.
It has been 85 years since Tomba's discovery. And humankind has, at last, witnessed the true face of Pluto. What we found was a spectacular landscape created by nitrogen glaciers. Where then did this nitrogen come from? A young up-and-coming scientist is seeking to answer this question. Planetary geologist Kelsey Singer is focusing her attention on an image taken by New Horizons from the other side, after it had passed Pluto. This blue ring, seen here backlit by the sun, is Pluto's atmosphere. Pluto is enveloped by a thin atmosphere made of nitrogen. The amount of atmosphere varies from planet to planet. Mars, which is 1/10 of the mass of Earth, has an atmosphere that's only 1/100th of the amount found on Earth. The Moon, with a mass 1/100th of the Earth, has no atmosphere. Small celestial bodies have weak gravity and therefore cannot keep hold of atmospheres. But then, how can Pluto, which is smaller than the Moon, have an atmosphere?
This gas represents Pluto's atmosphere. And as you can see, it's leaving the glass, and it needs to be resupplied from below by this ice that's going directly from a solid to a gas.
Singer believes that when Pluto's atmosphere decreases, it is replenished from below like this.
You'd need a mechanism to get the nitrogen out of the middle of Pluto. And one of those ways, and really one of the only ways, is through geologic activity. And so that could be anything from some kind of tectonic movement that opens up conduits for the nitrogen to get out. It could potentially be something volcanic. We don't actually know at this point.
This is Yellowstone National Park in America. Huge torrents of hot water are erupting out of the ground. Singer's theory is that there are features like these geysers on Pluto, which carry up nitrogen from inside. If geysers were found, it would show that Pluto continues to experience energetic geological activities, and it would be a huge discovery. Let's hope it's not long before they're found. New Horizons also directed its attention to Pluto's moons. This is the U.S. Naval Observatory, located atop a hill 7 kilometers from Lowell Observatory. The astronomer who first discovered Pluto's moon still lives nearby. This is Jim Christie and his wife, Charlene.
Oh, yeah, that's great.
In the 1970s, Christie was working at the Naval Observatory, making detailed observations of the moons of Uranus and Neptune, which Voyager planned to explore. Christie soon got used to his work and began making observations of Pluto too. Then, in 1978, a surprising discovery was made. These two images were captured at the time. The black mass is Pluto, but in the right-hand image in particular, one part bulges out. These images confirmed that Pluto had a moon. The person who discovers a moon is given the right to name it. And the newly married Christie came up with a romantic name. In America at the time, thanks to accelerator experiments, new particles were being discovered practically every year and were given names such as Scion and Tauon. This inspired Christie to take his wife Charlene's nickname Char and add on to make Sharon. The only problem was that moons are usually named after gods. But when he looked up Sharon in the dictionary, he was surprised to find it was, in fact, the name of a Greek god, spelt the same but pronounced Charon.
I opened it to C-H-A-R-O-N, and there it was. The boatman who rowed the dead souls across the river Styx into Hades, the domain of Pluto.
And so the moon was named Charon, supposedly after a god with deep ties to Pluto. However, because of this backstory of Christie and his wife, people still refer to it as Sharon.
So many husbands promise their wives the moon, but mine delivered. It was an honor. I couldn't believe it. He said he wanted to name it after me, and he did. It's amazing.
Charon's orbit was later identified in detail. Its orbital period was the same as the rotation period of Pluto, which spins on its side, and the two rotated, always with the same sides facing each other. The image that seemed to show a bulge on Pluto had actually captured a moment when the two were in line with each other like so. The New Horizons camera was also pointed towards Charon. Its diameter is around half that of Pluto. Although it is covered in ice, it is mostly gray in color, unlike the light brown Pluto. A huge valley, measuring over 1,000 kilometers long, was also discovered. Pluto and Charon were a complete contrast to each other in appearance. Why are two bodies with such dissimilar characteristics rotating around each other? Robin Canup is researching the origins of Charon. Canup was the scientist who developed a simulation to show that an object the size of Mars collided into Earth and created the Moon, what is known as the giant impact theory.
I've spent a lot of my career thinking about the formation of Earth's moon, which we believe formed from a large impact. And this led me to wonder about forming Charon. So this object up here, that's the impacting object, and the larger object is Pluto, right before the collision. So what you'll see here is the collision takes place. It's an oblique collision, so it starts Pluto spinning with a fast rate. And a large portion of the impactor recollides with Pluto, and part of it is slingshotted into orbit by the distorted shape of Pluto soon after the impact.
According to the simulation, if Pluto collided with an object slightly smaller than itself, in just one day, a moon would be created that rotates closely around it. It was this oblique collision that triggered the sideways rotation of Pluto, according to Knup's theory.
So we believe that the Pluto-Charon system formed more than 4 billion years ago, and that the properties of the system that we see today are therefore a relic of the conditions that existed in the very earliest solar system as the planets were forming.
Charon is not the only moon of Pluto that helps us understand the history of the solar system. We know that there are 4 more small moons further out. The New Horizons camera was also pointed at these small moons. These are the images it produced. The moons range in size from a few kilometers to dozens of kilometers. Instead of being spherical, they are all irregular in shape. By focusing on their shapes, it is thought that we can tell how the small moons were formed. Harvard University's Scott Kenyon is researching the origins of the solar system. Let's look at the results of Knup's calculations once more. Pluto and Charon were created after a collision. But that's not all. Shards of ice, shown in light blue, are also being scattered all around. Kenyon calculated how these ice shards would change over time. After carrying out repeated simulations, he found that over time, the shards stick together and grow into 4 or so moons, or satellites, as they are also called.
So the basic idea of the growth of the satellites, or the growth of any planet, is agglomeration. So 2 objects collide and merge, and in so doing, make a bigger object. There might be a little bit of debris that gets cast off, but mostly when 2 objects collide, they merge and they get larger and larger and larger as they merge with more and more objects. I mentioned that the satellites can form from collisions of objects, and you can sort of imagine that Hydra could be the collision of 2 objects, where this bottom part is one piece, and this top part is another piece, and so they came together like this.
Let's take a closer look at the small satellites. It does indeed look like the result of 2 bodies merging together. 4.6 billion years ago, in a place far away from the Sun, icy objects of varying sizes are thought to have collided and merged, over and over again. Scientists are now trying to discover what this nascent solar system was like. New Horizons has moved away from Pluto. In the control room, preparations are underway for a new exploration mission. Ahead of the launch, the exploration team had been using the world's biggest telescopes to scope out their next target, which would take New Horizons beyond Pluto. But even after 10 years, they could not find a single celestial object that the space probe would be able to reach. One of the scientists who took up this difficult challenge was Mark Bowie. Bowie used the Hubble Space Telescope to carry out around 200 hours of observations over the course of 4 months, starting in June 2014. What he finally discovered was this object inside the Kuiper Belt. Its size is thought to be under 50 kilometers wide.
And I'm not finding anything. I'm looking at image after image. Nothing's there. Nothing's there. I don't even know what I'm looking for, what it's going to look like. And this image comes up on my screen, and in just an instant, just like that, there's a real object. We found one. Finally, after 10 years of effort, I got a result. And that was an immense relief, but also very, very exciting.
On October 22nd, 2015, having completed its exploration of Pluto, New Horizons fired its thrusters for 16 minutes.
RF is also nominal or just
Copy that. RF is nominal. Thank you.
After performing 3 further engine burns, on November 4th, the probe entered the orbit towards its next destination.
This target, which we hope to fly by, will have set a world record for being the shortest time between the discovery of the target and exploring it with a spacecraft ever. Well, for the science team, we're busier than ever because now we have data and new data every week coming from the spacecraft. And we also have to plan our mission to the Kuiper Belt object.
Pluto, formerly known as the 9th planet of the solar system. Having seen its true appearance for the first time, we can appreciate anew the richness and diversity of our solar system. And now, humankind is endeavoring to reach new frontiers, even further beyond. New Horizons is scheduled to reach its next destination, 2014 MU-69, in January 2019.